Please focus. Don't do anything else. Focus, please. You ready? Thank you. So I want us to do theorems within the next 20 minutes. It doesn't take time. First is the angle in the semicircle, and the second is the theorem with cyclic quadrilateral. You all know what a semicircle is, yes? To have a semicircle means that you must see the line called what? Speak louder. Diameter. So if you have a diameter, of course, to know that it's a diameter, you see something to indicate that this is the center. Jovino, you're not different from everybody. You see something to indicate that this is the center of the circle. If the line passes through the center of the circle, it means it's a diameter. And the most common way to show that is to put letter capital O here. O means center of the circle, commonly used. Understand? So this is the diameter. Of course, if I do the same here, this is the diameter. Okay? So what this theorem is saying is that the angle in a semicircle is right angle. Meaning, if I use the end of my diameter in the same segment, wherever they meet, they must form angle 90 degrees. That's all. So, they meet here. This angle must be 90. Does that make sense? If both of them come here to meet, this angle also must be 90 degrees. Understand? If they decided to go in the opposite direction and they meet, this angle must be 90 degrees. As long as they start from the ends of the diameter. So you can see that the angle is in a semicircle. That's what we are saying. Understand? It's in a semicircle because the diameter tells you the origin. So this segment is actually a semicircle. It's half of the circle. We just say angle in a semicircle is right angle. That's the short form to state your reason. Angle in a semicircle is right angle. Can we say that together? Angle in a semicircle is right angle. That's all. Now, when you form a right angle, you might end up forming a right angle triangle, right? Then everything you've been doing about right angle triangle comes in. Does that make sense? Like the first one. I want to find x. What is my x?
50.
50. Understand? Why is it 50? Because only one angle, only two angles are missing. How do you know it's 50? Anyone want to explain? Yes, Tomas.
The angle at the top is 90 because...
Don't call it angle at the top. Use the statement we just said.
The angle in the
semicircle
is 90 degrees.
90 degrees.
So x has to be 50.
So you add together. Can you see that? So everything else is exactly what you've been doing. Look at this. What do we do here? Anyone? Yes, sir.
First, the angle of the semicircle is 90. So the remaining angles in the triangle add up to the other 90. So 3x equals 90 and x is 30.
And that's it. Understand? So the first thing you will say, if I want to do it, you can label this as y. Then you say y is equal to 90 degrees. And your reason will be angle in a semicircle. That's all. That's your reason. Understand? Then you say, oh, x plus y plus 40 is equal to 180 degrees. And this means angles in a triangle. Understand? And then x plus 90 plus 40 equals 180. Then my x will be 180 minus 90 minus 40. And that's how to properly explain how you did it. Understand? Then you do the same here. This is y, you get y is equal to that. You form the equation, 3x is equal to 90 eventually. Understand? But you must work it out like this. What about this one? It says radius is 6.5. What do I start with? Yes, Jubino.
The hypotenuse is 6.
Say that again?
The angle on the semicircle is 90 degrees.
So I can call that maybe angle theta, for example.
Plus
then you say theta is equal to 90 degree, right? Angles in a angle, okay, because it's one, in a semi-circle. But this has nothing to do with what we are looking for. So how does it help? Yes, sir.
So you can either use Sokata or you can use Pythagoras theorem, because the hypotenuse can be found when you double the radius, because the diameter is just double the radius.
The diameter is double the radius, so yeah, it's making a good point. Netanya, take over.
Yeah, I was gonna say something.
Yeah. Okay. So this is 90. You don't need Sokatua. Can someone tell me why we don't need Sokatua?
Because you already know two. Because you already know two sides.
We already know two sides. This is a right angle triangle. This theorem is only establishing the fact that the triangle is right angle. Understand? The x you are looking for is one side. One other side is given. In fact, the third side is given. Why? Curtis, how do I know this side is given? No idea? Manuela? Are you?
The diameter is just 2 times
The diameter is just 2 times the radius. This is the diameter, right? It passes through the center, so that's the diameter. Diameter is just 2 times the radius. Radius is given for a purpose. Understand? So as a result, this side, so if I label this triangle PQR, you're welcome to label if there's no label, so you can explain better. Then you can say, oh, PR is just 2 times 6.5, which is 13. Then Pythagoras theorem. Okay? Hypotenuse square, so that's like c squared is equal to a squared plus b squared. Substitute for me, together, everybody.
13.
13 squared, maybe x squared plus. This is what you solve. Okay? This angle is not for you to use Sokatua. This angle is to establish that it is a right angle triangle. Understand? Because you can't say sine 90. If you say sine 90, this is opposite, so where is the hypotenuse? You get the point. So it doesn't make sense. So 169, you get what I mean now? X squared plus 144, and we're going to get 5 eventually. So x squared will be 169 minus 144, which means x squared is 25, then x will be square root of 25, and x is equal to 5 centimeters. That's it. Okay, and for this one, again, we establish the 90 degree, right? So, because you don't need theta here, because it's labeled. The best way to communicate is to say, anybody want to try? Yes, sir. Angle ACB is equal to 90 degrees. That's the best way to communicate, because it's already labeled for you. Okay? I ask you to introduce the label when there's no label given. But if the label is given, use this point to describe it. Understand? And of course, you put your reason. Angle in a semicircle. That's the reason. Someone is playing with spoon or something there. So, since this is 90, then you have a right angle triangle. Understand? So, Tiago, what can I use to get my x? Sokatua. Very good. James, which of these Sokatua do we use? Probably.
No, probably
Sine. Let's look at it. Are you sure? Final answer. What is the first thing you should do? Label. So let's label. So which one is opposite? AC is opposite. Hypotenuse? AB. And adjacent will be the other one. So think again. Which of the trig ratio? So go with sine. What is your sine? Let's write the Sokatua somewhere. But remember, Sokatua. Sokatua.
Oh, I mean cos.
Okay, so it's cos, right? Because we have our AB, which is this hypotenuse. Then we have our BC given, which is the adjacent. So that's cosine. So we say, oh, cos theta is equal to adjacent over hypotenuse. Then I substitute. This time, cos theta is cos x. Adjacent is BC. No. Yeah, 6. And hypotenuse is 10. Understand? So x will be a cos of 6 over 10. And what is that? 36.9 maybe? Is it 36.9? Or 36.1? I don't know.
53.
53? Oh, sorry, my bad. I guess I was thinking about the other one. 53.1. Then the other one is the 36.9. So this must be the 36.9. Okay? So can you look at the worksheet that I just gave you? For the next 5 minutes only, I want you to do maybe 3 on the first page. Maybe we pick the extreme ones. The extreme means the first 2 on that paper and the last 2 on that paper. Then go to the next page and just focus on the last 3 on that paper. Okay? Wherever you stop within the next 5 minutes, you can continue at home. All right? Okay. Try to do something. Yes, sir. Of course. Are you sure we got all this explanation?
Yeah. Yeah.
Okay. to stop you in a minute. Okay, good stop. So this is the second one. And we are almost at the end of the cyclic theorem. Again, I'm sorry that I'm rushing this. I just need it to be on record, then you can work on it, take your time over the break. Understand? The second part is the cyclic quadrilateral. Of course, if I do not have this word, you know what quadrilateral means. What does it mean again? The shape with four sides. So when we say cyclic, from the word circle, it is inside a circle. Not only inside a circle, all the vertices are touching the circle. When we say all, is 3 allowed? No. All means all the 4. Understand? Can you look at the board, everybody, and tell me, is A, B, C, D a cyclic quadrilateral?
Yes.
Yes.
Is P, Q, R, O a cyclic quadrilateral?
No.
But it's inside the circle. Anna, why?
Because one of the angles touching each other.
Which angle is that? The angle at O. Because one of them failed to be. This is no longer a cyclic quadrilateral. So this is a cyclic quadrilateral, but this is not a cyclic quadrilateral. Understand? So now that we understand what a cyclic quadrilateral is, the theorem here is simple. If you see a cyclic quadrilateral, the angle facing each other add up to 180. We say they are supplementary angles. Can I show you something quickly from the previous theorem? Can we have it here?
Yep.
If you have this, remember we did something like this, we had this and that one. You remember this kind of question? And like that, remember? So let's say this angle is 50, yes? Then this angle will be what?
100.
And the angle at the back of 100 will be what?
260.
260. Then which is relating to this one, which is what now?
130.
What do you notice about 130 and 50 facing each other? Is this shape ABCD cyclic quadrilateral?
Yes.
Okay? So here, what will be the summary? What plus what is 180? A plus C is equal to? And B plus D is equal to? That's all. That's another simple theorem. Okay? Now let's apply it to the discussion. Which one is easy to get?
A.
A. And A is what? Without working it out. Then X will be what? Without working it out. As simple as that. Let's look at this. I want to get my X, right? I can't get my X directly. Oh, there's an illustration I always give my students in Nigeria. Coordinate geometric question, a circle geometric question, it's like trying to locate Matthew, given James' location. Matthew is who you want to find, but James is what you have. And the question, the logic is arranged such that James doesn't have direct access. You only have access to the next person beside you. Which means, with James as known clue, you locate Kiana. With Kiana as a known clue, you locate Wachok. Then you locate Manuela. Then you locate Corinne. Then you locate Juvino. Then you locate Oscar in order to find James, which is the main question. So you walk backward. Okay? How do you walk backward? I need seriousness. I have just 2 minutes, so I don't want distraction. How do you walk backward? This is who you want to find. Then you ask yourself, oh, if only I can locate Oscar, then I can get James. I can get Matthew. Am I making sense? Then you start thinking, how do I find Oscar? Oh, if only I can find Juvino, then I can locate him in order to find my question. Am I making sense? Then you say, do I have Juvino's location? No. Oh, if only I can locate Corinne. Then you think backward. That's the logic of coordinate geometry, circle geometry. Okay? In this case now, we will say, oh, if only I can find this. Right? Then I can use cyclic quadrilateral and find my X. Then you try to see, can I find this? You think of different ways. Of course you can find it. This is a triangle. This can give you 100. Right? 100 plus 30 can give you this. And when you find this, you find this one. And when you find this one, then you're able to find your X. That's one way. Am I making sense? Another way will be, oh, if only I can find this, then I can consider what triangle? If I can find this, I can consider one particular triangle in order to get this. What triangle is that? Say it out, no time. PQT. The big triangle, where this is assumed not to exist. So you can say this plus this plus this is equal to 180, right? So you see, this is what we are looking for. Then we say, oh, if only I can know this, I can consider the whole triangle. Then you think, how can I know this? Is there a way to know this?
Yeah.
How? Cyclical opposite angle to? Opposite angle to what angle?
Angle S.
Angle what? There's a number. Come on.
80.
80. This is opposite to 80 in a cyclic quadrilateral. So this must be what?
100.
100 plus 30 is 130, and this is 50 again. Bless you. Understand? And if you do the other way, if you know this, then you know this, right? So to know this, you must know this. Oh, to know this, you must know this one. Right? Now if I find this first, I get 100. 130. Then this must be 50. If this is 50, this is 130. If this is 130, this is 50. Again. Can you see the logic? That's how you do cyclogeometry problem. And there are many ways to do it. Just explain your procedure, and it's fine. Okay? So I'm going to stop here, and I'm going to pass this out. Again, you don't have to do it at home, but at least you have a video record. Then you can solve it later. Okay? Please, when I give you, pass to the next person. And do not leave your seat until you get a paper. Cyclic quadrilateral, angle semicircle. This will be for William. Okay, we need one more. Okay, first row quickly. We need one more here. We need one more here. You don't get? Guys, there are papers are somewhere with some people. Pass it across. Maybe some people took 2. He couldn't get and he couldn't get. So what's going on? Please check cyclic quadrilateral. Some people didn't get. Hello, check your paper, please. You might be having 2 with you.
Oh boy.
The paper you just took now, nobody took extra. Is that extra? Really? Is that extra? Okay, who did not get? Because I don't have time to investigate. 2 people. I'll print for you, but somebody definitely has it. Please, you're late for biology. I'm so sorry, I'm so sorry. All right, let's go. Jenny and Irene later. Let's go for biology. Can you turn that off now? Sir.